So this is my data set. So now we will try to create an algorithm in Python language. So here we will call some basic and important libraries to work. So Sklearn is one of the most important packages in machine learning, and it provides the maximum number of functions and algorithms to use clustering. We need to call it from Sklearn package. So to get some data set, we can generate a random sequence by using NumPy. By the above line, we get a random code having 100 points, and they are into an array of shape 102. We can check it by using this command. Now we will train our algorithm by processing all the data. Here the number of cluster will be 3. Error pala. Ito pala yun. So we can see that because of manually choosing the number of centroids, our clusters are not very much segregated. A cluster have a similar set of information, and our aim is to make the cluster as unique as they could. It helps in extracting more information from our given data set. Thus, we can plot an elbow curve which can clearly depict a trade-off between the number of centroids and information gain. The curve clearly states that if we choose the number of centroids at 7, 8, 9, or 10, then we have a better chance of fine clustering. So this curve helps in deciding between computational expense and acknowledged gain from a dataset. Now let us select the centroids of 10 so that we have 10 separate clusters. Regression. This is the example of data set of regression. So, without going into the mathematical details, we present the result here. For generality, we define x as feature vector and y as response vector. So this is the output. Estimated coefficients B0 and B1. So let's go to classification. This is the result pala sa dito sa code na to. The residual errors. Let's go to the classification. For example, you can use a function, the load iris, to get the iris flow dataset. As you can see, the load iris function would return numpy array does not have column headers instead of pandas data frame unless the argument of frame is equal to true is specified. Also, we pass return xy true to the function, so only the machine learning features and targets are returned rather than some metadata such as the description of the dataset. So this is the output. (150 rows and 5 columns). So separating the features and targets is convenient for training a scikit-learn model, but combining them would be helpful for visualization. For example, we may combine the data frame as above and then visualize the correlogram using Seaborn. So this is the output. So from the correlogram, we can see that target 0 is easy to distinguish, but targets 1 and 2 usually have some overlap. Because this dataset is also useful to demonstrate plotting functions, but we can find the equivalent data loading function from Seaborn. We can rewrite the above into the following. So this is the output of So the dataset supported by Seaborn is more limited. We can see the names of supported datasets by running of this code. This is the output. Next is so if we need more than this, so this is the output of the data frame. Charis. And that is the output of classification. The output of cluster and classification and regression are different. This is the output of classification. And this is the output of regression. These residual errors. And this is the output of clustering. Thank you.